Hello class, welcome to STAT 1200. I am your instructor William Buellman, and today we are covering section 4.4, counting. The objectives for this section are to be able to count the number of ways a sequence of operations can be performed, count the number of permutations, and to count the number of combinations. Example 1, a certain make of automobile is available in any of 5 colors, black, white, red, blue, or green, and comes with either a large or small engine. And how many ways can a buyer choose a car? Well, let's list them. I have a black car with a small engine, or a black car with a large engine. We could have a white car with a small engine, or a white car with a large engine. Same thing with red. We also have blue as an option for a color. And finally, green. So out of the 5 color combinations and 2 engine combinations, this is the total list of all the different ways we can package a color with an engine. So the total number of ways is 10. Example 2. A local pizza parlor is offering a half-price deal on any pizza with 1 topping. There are 10 toppings to choose from. In addition, there are 4 different choices for the size of pizza and 5 choices for the type of crust. And how many ways can a pizza be ordered? Making a list for this would not be very practical. So how can we do this, right? Because we have 10 different toppings, 4 different sizes, and 5 different crusts. If we made a list, that's a lot. So we're gonna have to think, okay, what's a better way of doing this? If an operation can be performed in m ways and a second operation can be performed in n ways, then the total number of ways to perform a sequence of 2 operations is m times n. In general, if a sequence of several operations is to be performed, the number of ways to perform the sequence is found by multiplying together the number of ways to perform each of the operations. So what this is saying is if we can do something in m number of ways and n number of ways, and then a third thing in o number of ways, the ways we can do that operation is m times n times o, and it just goes on. Example 3. License plates in California contain 1 digit followed by 3 letters followed by 3 digits. And how many ways can different license plates be made? There are 7 operations in total. Choosing the first digit, then choosing 3 letters, and then choosing 3 more digits. There are 26 ways to choose each letter and 10 ways to choose each digit. So the total number of license plates available is equal to 10 times 26 times 26 times 26 times 10 times 10 times 10, which is equal to 175,760,000. Here's some practice for you guys. You're going to do the following 2 questions. When ordering a certain type of computer, there are 3 choices for the hard drive, 4 choices for the amount of memory, 2 choices for a video card, and 3 choices for a monitor. And how many ways can the computer be ordered? A second practice problem. A quiz consists of 3 true-false questions and 2 multiple-choice questions with 5 choices each. How many different sets of answers are there? Pause the video, work on each one of these, get the answer, and then come check the solution. The answers will be shown in 3, 2, 1. Here are the solutions. So for the first one, remember we had 3 choices for the hard drive, 4 choices for the memory, 2 choices for the video card, and 3 choices for the monitor. So we just multiply those all together and we get 72. For the second one, remember we had 3 true-false questions, so we have 2 choices. So 2 times 2 times 2. and then 5 choices for the two multiple choice, so times 5, which gives us a total of 200 different possible answer combinations. Example 4. 5 runners run a race. One of them will finish in first, another will finish in second, and so on. And how many different orders can they finish? So since nobody's finished the race yet, we have 5 that can finish in the first place. Once one of them finishes, there's only 4 left that are able to finish in second. Once that person finishes, there's only 3 left that are able to finish in third. Once that person finishes, there's only 2 left who are able to finish in fourth. And once that person finishes, there's only 1 person left who can finish in fifth. The number of different orders that the runners can finish is 5 times 4 times 3 times 2 times 1, which is equal to 120. And when we have this type of multiplication where it decreases by 1 each time, we have a special notation for that. That's this exclamation point that we call factorial. So that 5 factorial just means 5 times 4 times 3 times 2 times 1. Example 5. 10 runners run a race. The first place finisher will win a gold medal, the second place finisher will win a silver medal, and the third place finisher will win a bronze medal. In how many different ways can the medals be awarded? So since nobody's finished the race, there are 10 different possible choices for the gold medal. Once the gold medal winner is determined, there's 9 remaining choices for the silver medalist, and finally there's 8 remaining choices for the bronze medalist. The total number of ways the medals can be awarded is 10 times 9 times 8, which is 720 different ways. The word permutation is another word for ordering. When we want to count the number of permutations, we count the number of different ways that a group can be ordered. The number of permutations of n objects is n factorial. Recall, n factorial is equal to n times n minus 1 till we get to 3, 2, and we end with 1. In the last example, 3 runners were chosen from a group of 10, then ordered as first, second, and third. This is referred to as a permutation of 3 items chosen from 10. In general, a permutation of r items chosen from n items is an ordering of the r items. It is obtained by choosing r items from a group of n items, then choosing an order for the r item. The number of permutations of r items chosen from n is denoted as NPR. The number of permutations of r objects chosen from n is NPR, which is equal to n times n minus 1 till we get to n minus r plus 1, which is equal to n factorial over n minus r factorial. Example 6. 5 lifeguards are available for duty one Saturday afternoon. There are 3 lifeguard stations. In how many ways can 3 lifeguards be chosen and ordered among the stations? We are choosing 3 items from a group of 5 and ordering them. The number of ways to do this is 5 P3, which is equal to 5 factorial over 5 minus 3 factorial, which is equal to 5 factorial over 2 factorial, which is equal to 5 times 4 times 3 times 2 times 1 over 2 times 1, which that divides to 1, that divides to 1, which gives us 5 times 4 times 3, which is equal to 60. Thus, the number of ways is 60. In some cases, when choosing a set of objects from a larger set, we don't care about the ordering of the chosen objects. We only care which objects are chosen. For example, we may not care which lifeguard occupies which station. We might only care which 3 lifeguards are chosen. Each distinct group of objects that can be selected without regard to order is called a combination. The number of combinations of R objects chosen from N is NCR, which is equal to N factorial over R factorial times N minus R factorial. Example 7. At a certain event, 30 people attend and 5 will be chosen at random to receive prizes. The prizes are all the same, so the order in which the people are chosen doesn't matter. How many different groups of 5 can be chosen? Since the order of the 5 people chosen does not matter, we need to compute the number of combinations of 5 chosen from 30. So we have 30 choose 5, which is 30 factorial over 5 factorial, 30 minus 5 factorial, which is equal to 30 factorial over 5 factorial, 25 factorial, which when we do all that, we get 142,506. So that is the number of ways that we can choose 5 people from 30 when order does not matter. Example 8. A box of light bulbs contains 8 good light bulbs and 2 burnt out light bulbs. 4 bulbs will be selected at random to put into a new lamp. What is the probability that all 4 bulbs are good? The outcomes in the sample space consist of all the combinations 4 bulbs can be chosen from 10. So 10 choose 4 is equal to 10 factorial over 4 factorial, 10 minus 4 factorial, which is equal to 210. The number of outcomes that correspond to selecting 4 good bulbs is the number of combinations of 4 bulbs that can be chosen from 8. So we have 8 choose 4, which is equal to 8 factorial over 4 factorial, 8 minus 4 factorial, which is equal to 70. So the probability that 4 good bulbs are selected is equal to that 8 choose 4 divided by 10 choose 4, which is equal to 70 over 210, which is equal to 1/3. So the probability that we choose 4 good bulbs is 1/3.